Hey, seventh grade. So our learning target today is I can find odds and probabilities. So we're going to start by talking about the odds in favor. What does it mean for odds in favor? Well, we're really talking about the number of favorable outcomes. Now, I don't believe that you can see this right now on your screen. So you'll have to write this part in. I think that that was not typed up for you. So favorable outcomes. Odds in favor means the things that we favor, the things that we're for, and then on the bottom we'll put the things that are unfavorable or that we're not favoring. So the things we favor on top over the things that we are not favor. And sometimes we use a colon in between those instead of a fraction. So let's talk about what are the odds in favor for rolling a 6. Well, we're really saying how many ways can we roll a 6? We can roll a 6 one way. So that would be the favorable outcome. You can take the dice, roll it, and the number 6 is only on the dice one time. So how many things are not 6? 5. Those would be what we call unfavorable. So this is the number 6 one way. The not 6s are on the bottom. So we have a 1 out of 5 chance. Another way to write that is with a colon 1, colon 5. That's kind of probably the way I'm going to be doing most of my work is with a colon today. So what about this next example? What is the chance that we roll a number less than 5? So if you think of the numbers less than 5, that's rolling a 1, 2, 3, or 4. I can roll a number less than 5 4 ways. So there's 4 what we call favorable outcomes. These 4 favor the outcome. So how many numbers are not less than 5? 2. The number 5 and the number 6 are not less than 5. So we have a 4 to 2 odds in favor. 4 in favor, 2 against. Rolling an even number. Well, how many of the numbers in 1, 2, 3, 4, 5, 6 are even? Well, the even numbers would be 2, 4, and 6. So we'd have 3 for the evens and 3 against the evens. So we'd have a 3 to 3 relationship. That's odds in favor. Odds against works exactly the opposite. So we would basically just take that fraction and we would flip it. So we would say, what are the things that we're against or unfavorable outcomes over the favorable outcomes? Unfavorable over favorable. So exactly the opposite situation. So when people are talking about betting, now we're going to talk about what are the odds against that it will happen. So what are the odds against that we're going to roll a 6? Well, how many things are against getting a 6? Well, 5, 4, 3, 2, and 1 are all against getting a 6. So we would say 5 things would not be a 6. 2, that's called against or unfavorable, to 1 thing that is a 6. So we would call this odds against. We list the things against it or unfavorable first. Likewise, we would take this basically and flip it. Remember, rolling a number less than 5 were these 4 numbers. How many things that are a not less than 5? 2 things were not less than 5 because we're doing odds against now. And 4 things were for the number of 5. So it's a 2 to 4 odds against. 2 against, 4, 4. Rolling an even number, we would say how many are not even? 3. How many are even? 3. So the not evens to the evens, 3 to 3. All right, so let's try an example. So we have this dice. So you have a dice. These are the options, of course. So what's the chance of doing odds in favor? So in favor. So the things we favor to the things we don't, of getting a 2 or a 4. Well, that would be 2 things in favor, the 2 or the 4, 4 things against. We have a 2 to 4 odds in favor, odds against. Rolling an odd number. If we look at the odd numbers, odd, odd, odd. 3 things in favor, 3 things against. 3 of them are odd, 3 of them are not. Rolling a multiple of 3. So that'd be 3 or 6. Those are the multiples of 3. 2 things are in favor. The numbers 3 and 6 are multiples of 3. 4 things are not. So we have a 2 to 4 relationship. So let's do the opposite. Let's do odds against. What's the odds against getting a 2 or a 4? The things, cross off 2, cross off 4. That means 4 of the things are not 2 or 4. 2 of the things are. This would be odds against. It's basically taking that and flipping it. Same thing, rolling an odd. So we're talking about the things that are not odd. Not odd, not odd, not odd. 3 things are not odd, or what we call in math against, unfavorable. 3 things are. Rolling a multiple of 3. So we're going to talk about the things that are not multiples of 3. So I'm going to go ahead and highlight because it's getting kind of confusing. Not multiples of 3. These guys, not a 3, not a multiple of 3, not a multiple of 3. So the things that are not multiples of 3 are 4 things that are not multiples of 3 to 2 things that are. 4 things are not multiples of 3 to 2 things that are. Basically, we're taking the odds in favor and we're flipping it to odds against. So Best Buy has the following iPhone covers. Let's talk about what are the odds. What are the overall odds? Well, here's what we have. We have 3 pink, 7 blue, and 5 kind of fancy ones that have like bling on them. So what are the odds of buying a pink cover? So really talking about pink to the not pinks. So how many are pink? 3. How many are not pink? 12. Because these are the not pinks. 7 blue, 5 fancy. That's a total of 12. They're not pink. So my pink to not pinks would be a 3 to 12 odds in favor. Part B. What are odds of not buying a fancy color? So not buying fancy colors. So we're saying not fancy over the option. So how many are not fancy? So looking at the not fancies would be these two together would be 10 to the fancy 5. So 10 not fancies to 5 fancy would be a 10 to 5. Okay, on the top of the next page then, let's talk about how we calculate probability, a little bit deeper in calculation of probabilities. So I have a lock with the digits 0 through 9. So we have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's actually 10 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. The length of the combination is 4 digits. You are allowed to use the numbers more than once. What's the probability that your combination is this exact combination, 1, 2, 3, 4? So first of all, let's figure out the denominator. So we have a 10-digit lock, so I'm going to leave myself 4 blanks. I'm sorry, we have a 4-digit lock. I'm going to leave myself 4 blanks. So I have 10 possible ways to get the first digit, the second digit, third digit, fourth digit. It says that you're allowed to use the numbers more than once. So if I pick a 3, I could pick a 3 again. What's the chance that I end up with this? So the chance that I get a 1 in the first spot is I have a 1 out of 10 chance that I get a 1. What's the chance that I get a 2 in the second spot? I have a 1 out of 2 chance of getting a 2 in the second spot. What's the chance I get a 3 in the third spot? I have a 1 out of 10 chance that I get a 3. And a 4, I have a 1 out of 10 chance that I get a 4. So 1, 2, 3, 4. The chances that I get a 1 in this spot, a 2 in that spot, a 3 in that spot, a 4 in that spot, each of those is a 1 out of 10 chance. So I'm going to go ahead and multiply the numerators 1 times 1 times 1 times 1. Multiply the denominators, which gives me a 1 out of 10,000 chance. If we divide that, 1 divided by 10,000 and multiply by 100, that's a 0.01% chance that I get that locker combination of 1, 2, 3, 4. What's your probability in this next example that all your numbers are even? So we're saying, what's the chance that you get an even, an even, an even, and an even? All right, so we're going to multiply each of those out. It's a 4-digit number. Remember, doing 4-digit numbers. I have 10 numbers to choose from each time because we can use the numbers more than once. I could have the same digit over and over and over. What's the probability in the first spot that I have an even number? Well, over here in the set, if I look at the even numbers, we have 0, 2, 4, 6, and 8. It looks like we have 5 even numbers. So I have a 5 out of 10 chance. I have a 5 out of 10 chance that I get an even number in that first spot. Now I can use the digits again. So what's the chance that I get an even number in the second spot? 5 again. All the green highlights are eligible for the second spot. What about the third spot? All the green highlights are eligible for the third spot. So I have another 5 out of 10 chance. What about the fourth spot? Well, all the green highlights are eligible for the fourth spot. So I have another 5 out of 10 chance. Multiplying this out, then I have 5 times 5 times 5 times 5. 5 times 5 times 5 times 5 is 625. In the denominator, multiply those out. 10 times 10 times 10 times 10 is 10,000. I have a 625 over 10,000 chance that that happens, which is 6.25% chance that I get the digits, 4 digits that are even numbers. That's the probability that that happens in a combination because there's so many different combinations that are possible. Okay, so what's the probability that your combination is only numbers greater than 7? So remember, we're doing a 4-digit combination. I'm going to move those over so I have some space here. Okay. And I'm looking for all of these digits have to be numbers greater than 7. So if I go back through these numbers, and I'm thinking about the numbers that are greater than 7, I'm going to go ahead and highlight them in purple so I can identify which ones I'm looking for here. So numbers greater than 7 really are just the numbers, it doesn't say equal to, it says greater than, just these two. The number 8 or the number 9. It does say that I can use the numbers more than once. So each one of these, 10 things could possibly happen. I have 10 choices for each. For each one of those, I'm asking about what's the probability that I get a number greater than 7. The chance that I get a number greater than 7 in the first digit is 2 out of 10. I get to use the digits more than once, so I could use those numbers again. What's the chance in the second digit? Another 2 out of 10. The third digit, another 2 out of 10. The fourth digit, another 2 out of 10. So multiplying those out then, 2 times 2 times 2 times 2 gives me 16 over 10,000. 16 over 10,000. Tap number divided by bottom number. 16 divided by 10,000 gives me a tiny, tiny probability of 0.16%. It is not likely that you're going to pick a locker combination that has just the digits that are greater than 7, so the digits 8 and 9 in all 4 of the spots. A 0.16% chance that that happens. If I'm going too fast, go ahead and pause that video. Otherwise, we're going to move on to the bottom. I have a lock with the digits 0 through 9. The length of the combination is 4 digits. You cannot use the numbers more than once. So kind of same thing we did above, but instead of saying that you can use whatever digits you want, it's going to be that you can't. Once you pick a lock number, it's out. So here's our numbers. Okay. And it says, what is the probability that your combination is 1, 2, 3, 4? So you have a 10-digit number. I'm going to show my work up here just for space. 1, 2, 3, 4. I can choose any of these 10 digits in each of the spots, or in the first spot, I should say, in the first spot. What's the probability that I choose the number 1? Well, over here, there's only one number 1, so I have a 1 out of 10 chance. But remember that now in this one, you cannot use the numbers again. So then we would assume that that digit is gone. I've taken it out. So now there's only 9 digits left when I go to choose the next time. What's the chance in the second spot I choose the number 2? Well, there's only one number 2 in that. Now that's gone. I go to choose in the third spot. There's only 8 digits left. How many of them are the number 3? Just 1. In the fourth spot, there's only 7 left. How many of them are the number 4? 1. So really I have a 1 out of 10 times 1 out of 9 times 1 out of 8 times 1 out of 7 chance that I get the digits 1, 2, 3, 4. Operation says multiply numerator. If I get a 1, then I multiply the denominator. 10 times 9 times 8 times 7 is 5,040. Turn that into a percent, and the percent that I get for that is 0.02%. 0.02% chance that I get the digits 1, 2, 3, 4 if I cannot use the digits again. So the percent chance changed. In part B, what's the probability that all of my numbers are even? So an even, an even, an even, and an even. Multiplying them out. Okay. Now remember, we have 10 to choose from. So we're going to go back to scratch here. 10 to choose from. I'm going to pretend like none of that's there. I have 10 choices in that first spot. If I identify the even numbers, I have 2, 4, 0, 6, and 8. So I have a 5 out of 10 chance that they're all even. Okay, so now it says in this one, you cannot use the numbers again. So let's say I chose 0 as my first digit. Well, then 0 is gone. So when I go to draw the second time, there's only 9 digits left. And what's the chance that I choose another even? Well, there's only 1, 2, 3, 4 even numbers left. So I only have a 4 out of 9 chance on the second digit because I've already taken out the 0. Let's say then now I take out the 2. When I go to draw the next time, There's only 8 digits left to choose from because the 0 and the 2 are out. And only 1, 2, 3 of those are even. So I have a 3 out of 8 chance. When I go to draw again, let's say I take out the 4. I only have 7 left now because I've taken out 0, 2, and 4. And how many are even that are left? Just the 6 and the 8. So only 2 out of 6. So there's my digit, my probabilities of drawing 4 even numbers. You cannot replace them. So I multiply the tops. 5 times 4 times 3 times 2. 5 times 4 times 3 times 2 is 120. I multiply the bottoms. 10 times 9 times 8 times 7 is 5,040. Divide and multiply by 100. The probability that I get that combination of all even numbers is only 2.38%. Crazy that we get even as our probability. Mathematically, that is the real probability, however. Okay, part C. What is the probability that your combinations is only numbers greater than 7? Keep in mind, you cannot use the numbers more than once. Some of you know the answer to this already, but I'm going to start solving it to see what you come up with. So I have 10 choices for this first spot. I'm wondering about the numbers that are greater than 7. These are the only 2 greater than 7. 2 out of 10 chance. So let's say I choose the number 8, greater than 7. I take that one out. It's out forever. Now I only have 9 digits left in there. And how many of them are greater than 7? Well, just that one. 1. Great. So now I take that one out. I go to draw the next time for my third digit, and I only have 8 left because once they're gone in this example, they're gone. How many of those are left that are numbers greater than 7? Numbers greater than 7. Well, I took them both out, so I don't have any left. So I don't have any left here. So really what ends up happening in this problem is when I multiply this out, it ends up being a 0% chance, which we would call in math. This is what we call an impossible event. You could not draw 4 times or pick 4 digits where all 4 of them are numbers greater than 7, and they all have to be different because you can't use them more than once. So you have a 0% chance. So our summaries for today. Remember that odds are written as a ratio or a fraction. And the other thing I would say is, remember that probability is between 0 or 1, which means it's really kind of a percent, a decimal turned into a percent. So your homework tonight, you really need to follow along on that, but your homework tonight is page 17 and page 18 due tomorrow. Page 17 and 18 due tomorrow. Have a fabulous night, 7th grade.